So in this last video, we're going to talk about solving trig functions using factoring skills. So let's just refresh on factoring skills. I know we've been doing it quite a bit, but when we're factoring in algebra, we generally write things in parentheses. If we have something that is a trinomial, like what we have here, there are three terms. And we think about what two numbers that multiply to give us the constant. So in this case, 2 is very limiting and only can be 2 and 1 that multiply. And we need to put our x's down, and then we think about the signs. So for these signs here, they're all positive, so they're probably all plus signs. So let's double check. 2 times 1 is 2, and we always add to get the middle term, so 2 plus 1 is 3, so this does work. But in algebra, if you're solving for something, you also have to set the factors equal to 0 after to try to find x and get x by itself. So if I were to subtract over the numbers to try to get x by itself, I would get x equals -2 and x equals -1. It looks like I have two solutions for my x values. So we're going to do something very similar with trig equations. Taking the same concept in, I have something similar. I have cosines that's being squared, and there are three terms here. This kind of looks like a trinomial, kind of like that algebra problem, where I have to figure out what two numbers multiply to give me 2, which again is just 2 and 1, very limiting. So instead of putting cosines, just putting x's in the front, I need to put a cosine in the front to make that cosine squared, and then I'll put my numbers down, so 2 and 1. And then the right-hand side has to be 0, so that way I can get ready to solve. So once the factors is like this and this side 0, it's easy to set each factor equal to 0. But before I do, let's make sure that this trinomial is correct. So 2 times 1 is 2. 2 plus 1 does give me that 3 that I'm looking for. So now that I've checked, I'm going to set each factor equal to 0. And if I subtract the numbers over to try to get the cosine by itself, so from here, I'm using the skills that I learned earlier to try to find my angles. So I have cosine, and it's equal to -2 and -1. Now, I just learned recently in the last video, we mentioned how cosine can only be between, so just as a reminder, cosine can only be a range between -1 to 1 on the unit circle. So you can see here, this cosine is a -2. So if you were to put this in your calculator, you're not going to find any solutions because -2 is out of bound. So this is no solution. And if you don't believe me, just definitely use your calculator, find the inverse cosine of -1, and you'll see your calculator will reject you. So for this one here, cosine can equal -1 on the unit circle. So if you go to the unit circle and go to where cosine equals -1, or when x equals -1. Let's take a look. So if I go to the unit circle, I see that x is equal to -1 right here at pi. So notice there's a -1 here for x. I don't think there's any other x values that's a -1. At least I don't see. This one's for y. But it looks like pi is the winner here. So it looks like my x equals just pi, and that's the only solution that I found using the unit circle. So this time around, if I'm able to find it on the unit circle, I'm going to use the unit circle to find my solution. I'm not going to use the calculator. I don't use the calculator unless the numbers that I'm given are not located on the unit circle, because the calculator gives me like very decimal-y numbers, and I try to avoid those numbers. The unit circle has very clean, simplified angles or exact angles. But let's practice some problems on example 3 here. And some of these I might need to use a calculator, and some of them I might not need to. So we'll just see. This next one here is also a trinomial. It has a tangent in it, and there's a 3, there's a 4, and there's a -4. So I could try to do something like slide and divide, since the number in front of the square is a 3 instead of a 1. But before I do, let's see if I can try to guess the factors by just playing a little bit. So I always start by thinking about two numbers that multiply to give me 4, but could also give me the middle term that adds to give me the middle term. So I'm thinking perhaps 2 and 2. And if that doesn't work, then I'll go to slide and divide. So I'll bring down 2. I need a -4 and a -4 here. So then I'm thinking, oh, maybe one's a positive, one's a negative. But that's hard to tell that this one's a -4. So maybe not, but I'll just try something. So I'm just going to put things down first. So this is a tangent. Tangent here. And then one of these tangent needs to be a 3 because 3 times 1. So I'll give the 3 to the first one here. And if this doesn't work, I'll give the 3 to the other one. So I'm just playing around and seeing if this factors out to be correct. So 3 tangent times tangent is 3 tangent squared. So this does work. Positive 2 times -2 does give me -4. So I got these first and last terms. I need to make sure that the middle terms work out. So when you multiply the inners, that's 2 tangent. And when you multiply the outers, that's -6 tangent. So if you take -6 tangent and add it with 2 tangent, the middle term. So if you take the outer and you add it with the inner, you do get -4 tangent. So this works. And so if it didn't work, I just keep playing with the numbers until I ran out of ideas, and then try to use slide and divide. You can use slide and divide in the beginning, and then find your factors too. So once you have your factors, you're going to set this equal to 0. And so I'm going to, oops, I forgot to set this one equal to 0, my bad. So I'm going to subtract the 2 over to the other side. And then it looks like I have 3 tangent equals -2. I'm going to divide by 3, so that cancels. So my tangent here is equal to -2 over 3. On this side, it looks like I just have to add 2 to both sides. Now, remember from the last video, we learned that tangent can be any number. Tangent doesn't have a limitation when it comes to the range. It can be anywhere from -infinity to +infinity. So in this case, I can probably plug these into the calculator and find the answers. So tangent is kind of hard to find on the unit circles because I have to figure out the values of sine and cosine when I divide. That gives me tangent. So for this case, I'm just going to go ahead and use the calculator just for time's sake. So if I were to plug this into the calculator, I would have tan inverse 2 over 3. And I would also have to plug in tan inverse of 2. So I've taken the inverse of both of these, plugged these into the calculator. The first one gives me, so this one gives me a -33,690 in the calculator. All right, so let's talk about negative values. If the calculator gives you a negative value, put it on a graph or a coordinate system to understand what this negative value means. So remember, in the direction, it says it only wants the numbers between 0 and 2 pi or 0 to 360 degrees. So only positive values from 0 to 360. So if we get a negative angle, it's out of bound, and we're going to have to change it back to a positive. So first off, where is tangent a negative number? Well, let's see. Tangent is positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, and negative in the fourth quadrant. So tangent is negative in the second and fourth quadrant, it looks like. Only positive in the first and the third. So since we have a negative tangent value, -2 over 3, and we got this angle here, so -33 degrees is about right here on the unit circle. So that kind of makes sense why this is down here in the fourth quadrant. So this angle definitely does exist, but we need to write this in terms of a positive number. So what I could do is take 360 and subtract about 33 degrees. If I were to do that, it looks like my x value would be 326.3 1 degrees for my first angle. And then if I were to find this angle here, it's about 33 degrees from the x-axis. So if I were to draw about 33 degrees up, this would be 30 degrees above 180. So if I take 180 and subtract it by 33.690, I would get about 146.30. So these are my first two angles that I found for just negative 2 pi over, or negative 2 over 3. This one is where tangent is a positive 2, so I'm going to type this in the calculator. And this time I actually get a very nice answer. X equals 63435, so a positive angle. So I don't have to worry about this being a negative angle. Now I do need to figure out where tangent is positive. So tangent can only be positive, all students take cash, in the first quadrant and in the third quadrant. So we actually found the angle for the first quadrant because we got about 63 degrees. So the other angle that is in reference to the third coordinate system is 63 degrees down. So from 180, it's about 63 degrees downwards. And so if I take 180 and add 360, I could find my angle. And so that would give me 243 degrees, and about 435 is my decimal. And so there we go. We have our angle. So this one's quite a lengthy problem because there are 4 solutions you have because there are two tangents. So whenever you have something that is squared, so notice this original problem is squared, you might have to find 2 angles for your answer. So in the past, when you're dealing with linear functions or linear trig functions, so like in the first part of this journal here, you had linear equations, you just had to find 2 angles. Now with quadratic equations or something that is a squared, you might have to deal with finding 4 solutions. So let's definitely practice this together. So for part B here, I have sine squared x minus sine x, 2 sine. So when I'm looking at this problem, I'm thinking, well, it's not a trinomial, but they both have sine, so perhaps I can just pull out one sine since this is sine to the first power here. So if I were to just pull out a sine, this would be sine x parentheses sine x would still be in the first term minus 2. Notice I pulled out one of the signs in each, so I put it outside. So I'd still have a sign left in the first term, and then this sign would have went away, so I still have a negative 2 on the inside. So this side is set equal to 0. So I can set only factors equal to the side on the right. So sine of x equals 0, and sine of x minus 2 equals 0. So I'm setting each factor equal to 0. Now this one's already done because this sine, I just have to figure out when does sine equal 0. So this I can probably find on the unit circle because when sine is 0, that's when y equals 0. So if I go to the unit circle here, let's see, here we go. So again, just as a reminder, sine of theta is equal to the y values. So we're looking for where sine is 0. So sine is 0 here at, well, actually angle 0. And sine is also 0 here at pi. And I don't think I see any other y values that are 0, so just 0 degrees or 0 radians and pi. So I'm going to write those 2 angles down. So I found 0 and 0 radians and pi to be my first solution. For this one here, I'm going to add over 2. So I'm looking for where sine is equal to 2. But this already starts to look very suspicious to me. You might remember me saying that sine, when we're talking about the range here, for sine, the range can only be between -1 and +1. So this too is out of bound. So this sign does not have a solution. This one actually is no solution for the second factor here. So these two are my only answer. So it looks like this equation is only true at 0 and pi for x. All right, moving along to C here. So C is very similar to the last problem. Notice it's only a binomial. So I'm going to try to see if I can factor out the greatest common factor. So they both have cosines. I can pull out a cosine, since I notice they both have cosines. So I'm going to pull out cosine of x. And I'm left with 3 cosine of x plus 5. So I only took out one cosine from each. So this would be what I'd be left with. I'm going to set each factor equal to 0, kind of like what I did before. And this one here is cosine of 0. So instead of sine of 0 this time, I have cosine of 0. So cosine is only equal to 0 at, it looks like, so cosine, by the way, is where x equals. So cosine equals 0 at pi over 2 and 3 pi over 2. And I don't think anywhere else does cosine equal 0. So only pi over 2 and 3 pi over 2. So notice that if I am able to find things on the unit circle, I'm not drawing out a coordinate system, I'm just grabbing it from the unit circle. So if I can find something on the unit circle, it's so much easier. So I have my x values for the first factor. I'm going to try to find my second factor here. So I'm going to need to subtract over 5 to try to get this cosine by itself. And then I'm going to divide by 3. So that cancels. And cosine is equal to -5 over 3. Now from here, I'm thinking to myself, -5 over 3, if I were to punch that into the calculator, -5 over 3, or I can always just take the inverse, but if I just put -5 over 3 in the calculator, it's -1.66 or 67 if you round. So this value is not in the range of cosine. So we mentioned before cosine is between -1 and +1 for the range. So this is also out of bound. So I already know this is no solution. But I also could just plug this into my calculator. Actually, let's go ahead and do that. So if I put cosine inverse -5 over 3 in my calculator, let's see what it does. Okay, my calculator throws me an error in domain, and so that tells me, yeah, it definitely does not work in the calculator if you were to find the inverse. So it looks like these two are my only solution, pi over 2 and 3 pi over 2. So it's really helpful to pay close attention to those like weird values for sine and cosine because it could be out of range. Now this one here almost looks like a trinomial to me. I noticed the tangent squared, and I noticed there's a tangent to the first power and a constant. So to try to solve this problem and make it easier on me, I think I'm going to move everything to one side and make it look like a trinomial and make one side equal to 0 so I can easily factor this. So remember, we can always move things to one side. So if I add over and subtract over 10 to the other side, this would be tangent squared x plus 3 tangent minus 10. And so all of these would cancel, but I would also add tangent x to that side and subtract it. So I've already written it down, and then 0 is now on the right-hand side. So now that I have a trinomial, I'm going to try to factor. So two numbers that multiply to give me 10 are 2 and 5, and they might help me add to give me 3 that I have in the middle. So I need two tangents because I need a tangent squared in front. I'm going to write the 5 down and the 2. So I need a plus sign on the 5 and a negative sign on the 2 since I have a negative 10. So 5 times negative 2 does give me negative 10, but 5 plus positive 5 minus 2 gives me that positive 3 that I'm looking for in the middle. So setting this equal to 0, I'm going to set each factor equal to 0. And from here, I'm going to try to get tangent by itself. So if I subtract over 5, this cancels, and my tangent is equal to negative 5 for the first trig. And then I'm going to add 2 to the other side for tangent, and then tangent is equal to positive 2. Now with this one here, tangent can be whatever number it wants to be. It's capable of an extensive range from negative infinity to positive infinity. So for tangent, we're going to need to use the calculator here. And that's because tangent, when it's negative 5, it doesn't show up on the unit circle since it's not an exact value on the unit circle. So I'm going to use the calculator this time. So I am going to be taking an inverse tangent to help me do this. So I'm going to type this part into the calculator, and I'm also going to type in tangent inverse positive 2 into the calculator. So plugging these in, this first one gives me x equals, it also gives me a negative number. So I get negative 78.69 degrees again. And so again, this is out of bound, so I have to change it into a positive number or a positive angle. So just as a refresher, I do need to look at the coordinate system. So all students take cash. Notice how this tangent is a negative tangent. So that means I'm going to be in the second quadrant and the fourth quadrant. And because this is a negative angle, this is in the fourth quadrant. And it's about negative 78 degrees. So if I could take, let's see, 0 and 360 would be here. If I want to make this angle positive again, I need to take 360 and subtract 78 from it, which would give me x equals 281.3110 degrees. And that looks so much better than what I had before. So that is the fourth quadrant angle. Let's try to find the second quadrant angle. So it would also have the same reference angle, about 78 degrees towards the second quadrant. So if this here is 180, let me move this, 180 degrees. I can take 180 and subtract 78 so I can figure out what this angle is. So if I take 180 and subtract 70, what was the angle that I got? 78.69. I would get, let me grab my marker here. I would get 101.310. I'll just make that a 0. And this here are my two angles. So notice when tangent is a negative number, negative 5, it's in the fourth and second quadrant, and I have a fourth quadrant, and this here is definitely an angle in the second quadrant. Now for this one here, let's draw a new coordinate system. So I'm going to go ahead and type this one in the calculator, and I get x equals, okay, so this time it's a positive number, 63.435 degrees. And so if I were to draw a coordinate system, all students take cash. I have a positive 2 as a tangent value, so I need the first quadrant and the third quadrant if I want positive tangent values. So I have a positive tangent value here in the first quadrant for 63 degrees, about 63 degrees. That's what I have. And so it should be about a reference angle of 63 degrees here. So if this is 180 and this is 63 degrees down, I need to add 180 with 63.435 degrees, and I would get, this would give me about 243.435 degrees as my angle. So I definitely now have a first quadrant angle, and this here definitely looks like it's in the third quadrant. All right, so we've done quite a few problems now. Our last problem here is E. So I realize with part E, I have a typo. This meant to be cosine. So put a little s here for cosine of x plus 1. My bad, I must have accidentally dropped the s. So this one's a little bit trickier because you have a cosine and a sine to work with. And this is different from what we're used to seeing because most of the time we've had always like terms. So when you have this situation, one of the tricks is to try to do some sort of manipulation. You can use trig identities, but in this case, sine and cosine don't have any relationship to each other except for Pythagorean identity. So let me write here at the very top. So one of the Pythagorean identity says that if you have sine squared plus cosine squared theta, it equals 1. That's the only relationship that they have with each other and nothing else. So I'm going to use this to my advantage. What I would like is if they were cosine and sine were squared. So I can force this upon. If I square this side, I can square the other side and make both sides squared. So I can force them to both be squared, is what I can do. And if I were to square the cosine x plus 1, I would have cosine of x plus 1 in twice. This side would just be sine squared x. Now from here, I'm starting to see some things. Like I could FOIL this out and make a trinomial, but the problem is I still have to deal with the sine squared. But here's the nice part. I can actually change this sine squared if I move this formula around and solve for sine, and I can write this sine in terms of cosine. So I'm going to try to make everything in terms of cosine, and to do it, what I'm going to do is move cosine, subtract it off of both sides, and make a formula where I have sine squared theta equals 1 minus cosine squared theta. So that means I can replace sine squared with 1 minus cosine squared theta because that's its identity. Anytime you have a sine squared, it's also equivalent to 1 minus sine squared theta. Or I'm sorry, 1 minus cosine squared theta. And so I'm going to FOIL this part out, and you'll see I have everything in terms of cosine now. So if I were to FOIL it out, I would get cosine squared x plus cosine of x plus cosine of x plus 1. Let's see, cosine times cosine is cosine squared, cosine times 1 is cosine, 1 times cosine is cosine, 1 times 1 is 1. So it doesn't look like any mistakes for me here that I've made. I'm going to add up the middle terms to make this cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine. And I start to notice I can probably move some of this stuff over to the other side and make a trinomial. So that's what I'm going to attempt to do. I'm going to subtract over 1, so that would cancel. I'm going to add over cosine squared. And so I would have 2 cosine squared, plus 2 cosine x. And it looks like the 1's cancel. So I don't have any 1's, and now my right-hand side is 0. So this is kind of nice because I have this side to be equal to 0. Both of these look very similar, so I can maybe factor out a GCF. I can factor out a 2 and a cosine of x. Since both of them have a 2, I can factor out a 2. Both of them have a cosine, so I can take out at least one cosine. And I'm left with cosine of x in front and maybe a 1. So if I were to redistribute, 2 cosine times cosine is 2 cosine squared. 2 cosine times 1 is 2 cosine. So now that I factored out the GCF, I can set each factor equal to 0. So if I set each factor equal to 0, I'm going to divide by 2 for this one. And so my cosine is equal to 0. And then this one I just need to subtract by 1. And so cosine is equal to -1. So I got some really clean answer here. I got 0 and -1. So I'm not using a calculator here. I'm just going to use the unit circle. So if I go to the unit circle, cosine is 0, or x is 0 at pi over 2 and 3 pi over 2. And if I go to the unit circle for -1 for x or cosine, that means my angle here would be at pi. So it looks like I have 3 solutions. X equals pi over 2, 3 pi over 2, and pi. All right, that is it for this video. If you have any questions, feel free to let me know. Bye, guys.